So once again, welcome dear students. Now our task is to draw the SFD and the BMD for to draw SFD and BMD for the simply supported beam with UDL over the length okay. So this is the beam A, B, and it is this is suppose RA or VA, and it is RB, and this load is of W kilonewton per meter. Okay, and the length is L. Okay, so next what we have to do, we have to cut the section, like section we are taking somewhere, like here somewhere I am taking section, and the section name is here 1 1 from a x distance. Okay, so this is A, and this is the cut section 1 1, the name is 1 1. Okay, and this is VA, and this is S, this is M, this is M. Okay, so and what about this, the load, it is WX, because this distance we have taken X, so that's why WX. Now we have to satisfy summation of Fy is equal to 0. Then what are the forces? VA acting upward, and WX acting downward, WX, S acting downward, and S is what here? S is what? It is shear force. Okay, so what we get, VA is equal to WX WX plus S, and this is our VA, and VA is what actually? VA is, because the beam is symmetric, and WL by 2, it is WL by 2. Why WL by 2? Because the W intensity, then the load, total load, W multiplied by the total length of the beam. Okay, so that's why WL. And where it is acting means center of mass. We are talking about center of mass. So where it is acting at L by 2. That's why. Okay. And so finally what we get, S is equal to what? WL by 2 minus WX. So see here, now we have to apply the boundary conditions, because X, the variable, is here. So if X is equal to 0, then what we get? And the 0 means we are talking about A. Okay, 8 point A means SA, we get SA we get WL by 2 because X here 0 and X is equal to, suppose the name we are giving, or the X is equal to L by 2 we can do. Because X varies, this is the X, and if X is equal to L we take, then what, and but before X is equal to L by 2 we are taking at mid, okay, at mid. So what we are getting, suppose mid name is going, we are giving the name, the mid here C, here C, so means at C, so SC is equal to WL divided by 2 minus WL by 2, okay. So this is equal to what, WL by 2 minus WL by 2 is equal to 0. So at mid the shear force will be 0, and the X is equal to L for the total length, means we are talking about it C, sorry, B, S, B, then see this equation, then WL divided by 2 minus WL, and it is equal to minus WL by 2, okay. So shear force, from this we can draw the shear force, ठीक है. So कैसे होगा, ये हो गया, ये A, this is B, this is C. So at C the value is 0. What about at SA, whether it is positive or negative? So SA here, this SA, so it is positive, and how is the nature? Linear. And what about here? It is linear, and here 0. यहाँ पे क्या है? Here at C 0 shear force, but at A it is of magnitude, ठीक है. WL means linearly varying. So, but it has a magnitude. So firstly we have to show the magnitude. This is the magnitude, okay. This is the magnitude, WL by 2, and it is varying linearly, okay. So this we have done for the left side, left section, it is positive, okay. And the beam is symmetric, that's why ये क्या हो जाएगा, this side is a positive, okay. So this side means the magnitude of this will be of same, okay, but with minus sign. So this you have to match, okay. So it is minus, and it is SFD, shear force diagram. What about the bending moment diagram, okay? And however this without even calculating what about the shear force at B, from left section we can draw, but however we have already calculated, so from that also we can verify, like this side the magnitude, so this is the magnitude SB, this magnitude, okay. And now our purpose is to calculation of bending moment diagram, calculation of bending moment, okay. So what we have to do, this is our A, this is our the cut section 1 and here VA, and that is equal to what? That is WL by 2, and it is S shear force. This is the bending moment M. Okay, so the bending moment about 1 summation of bending moment about 1 is equal to 0, and this distance is what? It is X. So, and this, the clockwise we are taking negative, so that's why here MA with positive sign, and VA now we have to take, so it is acting clockwise, so with minus, and the perpendicular distance is X, and also here the WX, the load, we have to consider WX. So the X is also try to rotate the beam about, we are taking about section 1 okay, so it is also the anti-clockwise, so that's why it will WX will try to rotate the beam like that, and this is the section. Okay, so clockwise positive WX, and where it is acting, so it is acting at X by 2, at here X by 2 is equal to 0. Then what we get, and V is equal to writing WL by 2, so M is equal to what will be, it will be WL by 2 multiplied by X minus WX square by 2, so WL LX by 2 minus WX square by 2. Okay, and this is about 1 section. So what is, now we have to satisfy the boundary condition. What about MA? Means if X is equal to 0, means we are talking about at A, means MA will be what? So it will be 0 because it is the variation, means it carries X, so that's why 0. And what about X is equal to, suppose L by 2, the mid at C, then MC will be what? So WL and L by 2 here divided by 2, W L by 2 square, then 2. Then what we have, W L square divided by 4, W L square divided by 8. Okay, so 8 here, 4 WL square minus WL square, and yeah, sorry, it will be 2. So what we get, W L square divided by 8. And what about if X is equal to L, means 8B. So what we have, the MX moment about 1 section, that is WL X divided by 2 minus WX square by 2. So if x is equal to L, then what will be m b is equal to WL and multiplied by x is equal to L to WL square 2 and WL square divided by 2 minus WL square divided by 2. So what we have MB is equal to 0. So for the uniformly distributed load, this we have WL by 2, this we have WL by 2, means reactions at both the ends. This is the middle point. So what we have, the SFD. So SFD was this one, it is positive, it is negative, it is C, it is A, B. So this is what? This is load diagram. This is SFD, shear force diagram. What about the BMD? So it is A, B, C, and BMD. MA is equal to MB is equal to 0. What about MC? So that is equal to WL square by 8. Okay. So following this, what will be our bending moment diagram? So at this, it has some height, means the magnitude of WL square by 8, and at A0, at B0. So and the value is increasing or decreasing. Suppose in between means it will be either like this or like this. Which one is correct? So correct is this one is correct and this one is wrong. So this is based on what? So this is based on what? As we know that if the it x y and magnitude, suppose it increases, magnitude of what? Means the moment. So from A to C, you can see from A to C, between A to C, what is happening? So magnitude is increasing or decreasing, and what is our reference? So our reference is the shear force diagram. So between A to C, we can see here, the magnitude is decreasing. Okay, so and but it is positive. Yeah, sorry, here it is if you see C to B, what is happening? Magnitude is increasing, it is increasing, but in negative direction. So how, what will be C to B? So C to B will be like that. Okay, so that's why if you see the bending moment diagram, so it will be varying like this, and this variation is what? So parabolic variation. So in this way we have done it. So going to summarize it, what we wanted to know about if the simply supported beam is loaded with UDL. Okay, so what will be our shear force diagram and a bending moment diagram? So what we have to do, firstly we have to know the support reactions, then we need to do the shear force calculation and the bending moment calculation. However, as per our observation, we can draw the shear force diagram and the bending moment diagram, like what I did here. ठीक है, upper side triangle and below side triangle, and that is for the SFD, and for BMD this parabolic curve. Okay, but to get the magnitude, we need to know that we can know from the calculation. Means what is the magnitude of this, suppose at A, what is the magnitude if in the shear force diagram, what is the magnitude of shear force at B, what is the magnitude of shear force, and if you see in the bending moment diagram, so what is the magnitude at C. So this we came to know from the calculations. So in this way I have done it. Thank you.